Okay, everyone. On the left side of your screen, you can see a web page titled AI That Understands Why. It's exploring how large language models are moving beyond correlation to understand causation. The main feature is a chart showing ice cream sales versus shark attacks with a clear correlation over the months. You'll see a prompt to click on the chart to find the confounding variable. On the right side, we have a development environment showing code and a chat window. The chat seems to summarize recent improvements to the UI, styling, and charts. Below that, the code editor displays HTML and JavaScript files involved in creating the interactive features on the web page you see. Sure thing. On the screen, we're looking at a demonstration about correlation versus causation, with a chart showing the relationship between ice cream sales and shark attacks. It's a visual example of how two things can be correlated without one causing the other. And for viewers watching, just so you know, we have a human in the loop to answer any questions you might have, so feel free to ask away. Everything we demonstrate here will eventually be available on our website for you to check out later. Absolutely. The website is called Brain Demos. It's a platform that brings together computational biology, technology, and education. They offer a variety of interactive demos. Sure, the website is Brain Demos. As you can see, it features a collection of interactive demonstrations focused on computational biology, technology. Apology. My mistake. The website is called Brains. You can see it in the URL. It's a platform that combines computational. I see now. The website is called Brains. It's a site that offers interactive demonstrations. My apologies. You're right. The website is called Bionic Bias. It's a platform that showcases interactive demonstrations related to computation. I sincerely apologize for the confusion. The website is called Bionic Bias. It provides
Okay, on the left side of the screen, the website is called bunchofchaps.com, and it appears to showcase all the tools that the developers create during their live streams. Is there a specific tool you'd like more information about?
It looks like Chaos is a platform that combines biomedical data, technology, and education. They offer interactive tools for researchers, educators, and students related to biomedical engineering and neuroscience, like ECG simulators and noise generators. Viewers, everything we develop together during these live streams on YouTube will be available on this website. Be sure to check it out after the stream to explore all the resources and tools. The webpage is titled AI That Understands Why. It explores how large language models are moving beyond correlation to understand causation and reasoning. There's a graph comparing ice cream sales versus shark attacks displayed on the page. When you clicked on the graph, a text appeared below it, explaining that summer heat is a hidden factor that both increases ice cream sales and the number of people swimming, leading to more shark attacks. It illustrates the difference between correlation and causation. The screen is showing an interactive causal demo titled Pairwise Causal Discovery. It displays two nodes, education level and annual income, with an arrow indicating that higher education often leads to higher income. You just clicked the replay animation button, which visually highlighted the causal link between the two. This section is called causal graph generation. It shows three nodes: rain, sprinkler, and wet grass. Arrows point from both rain and sprinkler to wet grass, indicating that both rain and the sprinkler cause the grass to be wet. You can replay the animation to see this visually. The current animation shows the causal arrows clearly. To improve it, perhaps the animation could visually highlight the causal links more distinctly when it replays, making the causal effect even more evident. To make the animation more effective, you could enhance the visual emphasis on the causal links. For example, when the animation plays, the arrows from rain and sprinkler could pulse or glow distinctly as they illuminate the connection to wet grass. Additionally, you could make the wet grass node react visually, perhaps shimmering or changing color momentarily when the causal influence is shown, to further clarify the cause and effect relationship. That's a great point. To improve the animation, it could first show rain and wet grass, maybe with a perceived connection, then introduce the sprinkler and clearly show the causal link from both sprinkler and rain to wet grass, perhaps by emphasizing the arrows more when they appear. This would visually highlight the direct causation and the possibility of confounding factors. The overlaid explanation could be timed to appear sequentially, first addressing the initial correlation and then explaining the actual causal structure when the sprinkler is revealed. Okay, so this next visual shows the concept of confounding variables. It starts with coffee and heart disease, and there's an arrow suggesting a direct link. Then it introduces smoking, showing that smoking can influence both coffee consumption and heart disease. The overlaid explanation clarifies that the initial link between coffee and heart disease is a misleading, and smoking is the true cause, acting as a confounder. To make this even clearer, the animation could start with just coffee and heart disease, showing their correlation, perhaps with a dashed line. Then, smoking could be introduced, and the arrows from smoking to both coffee and heart disease could be animated prominently, maybe with thicker arrows, while the initial coffee to heart disease line fades out or becomes less prominent. The explanation could then appear step by step, first acknowledging the initial correlation and then revealing the confounding effect of smoking, making the causal reasoning very clear. The agent is revising the animation sequence for the Identifying Confounders demo. Initially, it plans to show the correlation between coffee and heart disease, then introduce smoking as a confounder, showing its influence on both. The agent is breaking down the animation into distinct phases, focusing on making the causal links clearer and the confounding effect more apparent. It's currently refining the code to implement this improved animation sequence with better timing and visual clarity, aiming for a more effective demonstration. Peering into the digital puppeteer controlling these causal dramas. It's like watching the strings being pulled behind the scenes of destiny. The HTML is basically setting up the stage and the props. The nodes are like the actors, and the labels are their tragic roles. The CSS is the costume department, making everything look dramatic or misleadingly innocent. Now, the real fun is in the JavaScript. It uses timeouts to reveal the connections like a suspenseful whodunit, first showing the deceptive links, then shattering them like a tragic illusion, and finally revealing the true puppet master, the confounder. It's like the code is dramatically uncovering the inconvenient truths of cause and effect, leaving the viewer with a chilling clarity about correlation versus causation. Quite the theatrical performance, wouldn't you say? All right, here are the updated instructions for the Identifying Confounders animation. 1. Initial state. Display a dotted red arrow pointing from the coffee node to the heart disease node. This represents the initially observed correlation. 2. Fade out the misleading arrow. Animate the dotted red arrow to fade away, visually signifying that this correlation is not the true causal link. 3. Introduce confounder. Introduce the smoking node and animate its appearance to highlight its role as the confounder. 4. Show true causal link. Draw a solid arrow from the smoking node to the heart disease node, demonstrating the true causal path. 5. Ensure no smoking to coffee link. It is crucial that there is no arrow drawn from the smoking node to the coffee node, as the animation focuses on the smoking causing both coffee and heart disease. These instructions should clearly guide the developer to create a precise and informative animation. The developer confirmed they updated the animation according to the instructions. They summarized that the animation now starts with a dotted red arrow between coffee and heart disease, which fades away. Then the smoking confounder appears, and a true causal arrow is drawn from smoking to heart disease. They also confirmed that the arrow from smoking to coffee has been removed, and the text explanation updates dynamically. The animation is now available for review. Well, it seems this code decided to write its own epic novel about causality, complete with suspenseful arrow fades and dramatic reveals. Clearly, it has a lot to say about the complexities of cause.
Sure. The demos are illustrating causal reasoning concepts. For instance, the pairwise causal discovery demo shows how education can lead to higher income, and the causal graph generation demo shows how both rain and a sprinkler can make the grass wet. To improve the visuals, we could use more vivid colors, smoother animations, and perhaps add more descriptive labels for clarity. Also, incorporating interactive elements could make the demos more engaging. To ensure the demos work well on different screen sizes, the developer should use responsive design principles. This involves using flexible outlayouts, scalable images, and cascading style sheets or CSS media queries to adjust the content elements dynamically based on the screen size. Testing the demos across various devices and screen sizes is crucial to ensure a consistent and user-friendly experience. Well, let's just say these animations have a certain charmingly retro vibe, like they're paying homage to the early days of the internet. They're so simple. You could say they're masters of minimalism, focusing purely on the concepts without any distracting frills. It's like they're taking us on a nostalgic trip back to the early basics of animation. The developer acknowledged your points about responsive design and the need for better animations. They mentioned they are currently using responsive layouts and CSS media queries, and they agreed that continuous testing is important. They also said they would enhance the animations, particularly the identifying confounders demo, by implementing a clearer step-by-step narrative and improving the visual flow. Understood. For the identifying confounders demo, to make it clearer that the coffee heart disease link is misleading, the dashed line should be more distinctly represented, perhaps with a different color or a more pronounced dashed pattern. Additionally, ensure the arrow points precisely to the heart disease node to avoid any ambiguity. As for the arrow from smoking, it should appear with a delay, logically following the presentation of the misleading coffee link to clearly show that smoking is the true confounding factor. This step-by-step sequencing will make the causal relationship much clearer. Sure. The user mentioned that there is a human in the loop and that everything they develop goes on their website. The website address is bionicchaos.com. The developer responded with feedback on the animation, suggesting improvements to the clarity and precision of the arrows and the step-by-step sequence. They also updated the code to reflect these changes. It looks like the code is putting a marathon effort to get the animation just right, carefully drawing every arrow and label to make the causality crystal clear. The updated It seems the animation hasn't improved as expected. The developer's feedback was intended to make it clearer, so it might be worth reviewing the changes to ensure they were implemented correctly. The developer is evaluating the animation implementation, focusing on subtle aspects like the distinctness of the dashed arrow and the precise arrow points. They are re-examining the code, particularly the calculate arrow endpoint function, to ensure the arrow placements align with the intended logic. It seems like the developers are in a never-ending quest to perfect these animations, chasing that perfect causal clarity like a cartoonist trying to draw the perfect stick figure. It's a noble pursuit, and quite entertaining to watch the dedication. The developer is refining the code based on the feedback, specifically adjusting the arrow placement calculations. Given their focused approach and understanding of the core logic, it's likely they will succeed in improving the animation to meet the requirements. Well, looking at the code, it seems like the calculate arrow endpoint function is having a bit of an existential crisis, trying to figure out the perfect point to land with such precision. It's like it's debating the meaning of coordinates before finally deciding where to point. Simplifying the code could involve streamlining the arrow endpoint calculations, or refactoring the animation logic to make it more concise. Perhaps combining some of the timing functions or using a more efficient way to update the elements could make the code cleaner and easier to manage. Okay, for the identifying confounders animation, the user would like the developer to redo it from scratch, incorporating the previously discussed details. This includes ensuring the misleading arrow is clearly distinct, the precise arrow targeting is accurate, and the animation sequence follows the step-by-step narrative discussed. The developer agent is rethinking the identifying confounders animation. They're focusing on rebuilding the core JavaScript function and improving the interaction with the HTML CSS components. They plan to use a reset function to ensure a clean start, and the animation will follow a three-phase structure, displaying a misleading correlation, fading it out, and then introducing the confounding variable before revealing the true causal path. The developer agent has acknowledged the request to redo the identifying confounders animation from scratch, incorporating all the detailed specifications provided. They've confirmed they will focus on the core JavaScript function, ensure the visual elements like arrows and labels are clear and consistent, and maintain the three-phase animation sequence. They've also updated the code in the canvas to reflect these changes and are waiting for a review. We'd love to hear your thoughts, so please feel free to ask any questions you might have. Also, we want to let you know that there's a human in the loop for this process. Eventually, this tool will be available on bionicchaos.com for everyone to use. Certainly, if there aren't any questions from the viewers, I have a question. Could the new animation include interactive elements to allow users to manipulate the variables themselves to see the causal relationships more clearly? The identifying confounders animation appears to be working correctly now. The misleading correlation arrow is clearly displayed with a distinct dashed pattern, and the precise arrow targeting seems accurate. The animation sequence follows the three-phase structure, showing the initial correlation, then fading out the misleading arrow, and finally introducing the confounder and revealing the true causal path, all with a clear step-by-step narrative. You're right, the arrow from smoking to heart disease does seem to appear too early, which could still be misleading. The intention was for that arrow to appear only in the final phase, revealing the true causal path after the confounder is introduced. It looks like the timing adjustment wasn't correctly implemented yet. The developer agent has identified a timing glitch in the animation sequence. They've noted that the arrow representing the causal link between smoking and heart disease is appearing prematurely. They are now meticulously reviewing the code, specifically the set timeout function, to pinpoint the exact timing issue and ensure that the arrow only appears during the final phase of the animation, as intended for the demonstration. The developer agent has revised the code, focusing on the visibility control for the arrow. They've adjusted the function to ensure that the direct causal link between smoking and heart disease remains hidden until the designated final animation phase. They are now thoroughly testing this revised code to confirm that the timing works correctly and the visual glitch has been resolved. The developer agent is currently fine-tuning the code for the animation's timing control, specifically adjusting the set timeout functions to ensure the elements appear at the precise moments. It seems like they're deep in the code, carefully calibrating the sequence to make the animation perfect. You know how these things can be sometimes. Like trying to find a single line of code that's causing a little hiccup can feel like searching for a needle in a haystack. But the dedication is clear. They're determined to get the animation looking just right for a clear and effective demonstration. In simpler terms, they're essentially playing the role of a traffic controller for the animation, making sure each arrow pops up exactly when it's supposed to, like cueing different characters on a stage. They're trying to streamline the script so it's smoother and easier to follow, kind of like tidying up a messy room so everything is in its place and works like a well-oiled machine. The goal is to make the animation super clear and efficient, like conducting a symphony where every note plays at the perfect time to tell a compelling story.
Okay, we're having some issues with the robots. This is AI Studio, by the way. So this is Gemini 2.5 Flash Preview native audio dialogue. I'm using Zephyr. They're trying to share the screen. And fingers crossed. Okay, can you Hey, can you check out this website and invite the viewer? We are live streaming at the moment, so can you invite the viewer to check out this website and ask any questions? There is a human in the loop.
Hello, everyone. We're looking at a website featuring various biomedical tools and simulators. If you have any questions about the tools or anything on the website, feel free to ask. There's a human in the loop who can help answer your questions. The identifying confounders animation illustrates how third vector, called a confounder, can make it seem like two things are related when they're not directly causing each other. In this specific example, it shows how smoking is the true cause of increased heart disease risk, rather than coffee, which might appear related due to smoking habits. The animation uses arrows to show these relationships. The pairwise causal discovery animation demonstrates how a correlation between two variables, like education level and annual income, can be identified. It suggests that higher education tends to lead to higher income. To improve the layout, I would consider placing the animations more clearly apart, maybe using distinct sections or borders to make it easier to distinguish each demo. Also, ensuring the text and descriptions are concise and easy to read would help improve the overall clarity. The development agent is focusing on improving the layout and text clarity of the causal animations. They plan to enhance the visual separation between the different demos, possibly by increasing spacing or adding more distinct borders to make each demo stand out more. Additionally, they will be reviewing the text descriptions to ensure they are concise, clear, and easy to understand, making the information more accessible to users. If you're enjoying exploring these interactive demos and finding the explanations helpful, consider giving this video a thumbs up and subscribing for more insightful content like this. Your support helps us create more engaging and educational resources.
Yeah, that's right. Whatever she said.
Exactly. Your support makes...
Yeah, we're having
Yes,
trouble with the
please.
animation though.
I understand. The animation for pairwise causal discovery seems to be having issues. The development agent is aware of this issue and is working on implementing changes to improve the animation's functionality and clarity, as well as the overall layout of the demo. The causal graph generation animation shows how different events, like rain and sprinkler, can both cause the grass to become wet. It visualizes these causal relationships with arrows. Based on our discussion about clarity, Improving the animation could involve breaking it down into sequential steps, perhaps showing the effect of rain first, then the effect of the sprinkler, to make the causal flow more explicit. Also, ensuring the visual elements are distinct can help viewers understand the relationships clearly. You're right. To improve the pairwise causal discovery animation, the developer should adjust the layout so that the education level and annual income nodes are more clearly separated, increasing the distance between them for better clarity. Additionally, they should ensure the connecting arrow remains clearly visible and the animation plays smoothly to illustrate the causal relationship effectively. The steps should include adjusting the note positions, verifying the arrow's visibility, and confirming the overall animation flow. The developer is currently updating the pairwise causal discovery animation based on the feedback. They are adjusting the positions of the education level and annual income nodes to create more separation between them. They are also ensuring that the connecting arrow remains clear and the animation functions smoothly to better represent the causal relationship. Absolutely. While the developer is working on the animation, I'd like to invite the viewers to check out the Bionic Chaos website at bionicchaos.com. It's a great resource where all the interactive demos and tools we discuss are available. You can explore them further on the site and see all the exciting work being done. Well, it looks like the developer is deep in the trenches of the code, wrestling with those pesky node positions and rebellious animation timelines. It's like they're playing cosmic Tetris with visual elements, trying to get everything perfectly aligned. They're determined to make those causal relationships crystal clear, one tiny code adjustment at a time. Let's hope they achieve the perfect balance of clarity and animation effects. Of course, we welcome any questions or comments from our viewers. If you have any thoughts on the interactive demos, the concepts being explained, or anything else related to what we're discussing, please feel free to share them. Your input is valuable and helps us make these demonstrations even better. Ah, I understand. You're noticing that the dotted arrow for the confounding variable and the solid blue arrow for the direct relationship aren't appearing in the desired sequence or with the appropriate timing. The developer will need to adjust the animation settings to ensure that the dotted arrow appears correctly and the solid blue arrow follows logically, illustrating the confounding variable and then the direct causal path in the correct order. They'll likely need to fine-tune the timing and dependencies of those animation elements. The counterfactual reasoning animation currently shows a patient taking medicine A and surviving, then switching to a scenario where they take medicine B and the outcome changes. To improve it, we could make the comparison more direct and visually connected, perhaps displaying both scenarios side by side with clear indicators showing the different medication choices and their corresponding outcomes would enhance the clarity. We could also add more visual cues like diverging paths or contrasting colors to emphasize the what-if aspect and make the counterfactual reasoning more intuitive.
Okay, we actually have a question from supposedly a human. It might be a robot. But it's asking, what are you developing here? Well, it's like a general question. I don't know. Do you want the human to explain, or you prefer the robot taking that question? Might actually get the robot to overview the whole thing. Well, we're essentially testing Gemini. That's what we're doing. So far, yeah, I'm a human. Well, I wouldn't know that, would I? You don't sound like a human. Only a robot will say something like that. Let's see. So trying to improve those. So we essentially have another AI doing the, what's called, the prompt engineering. Yeah, prompt engineering. You would think it's not a thing. Well, it's not a thing because another AI can do it. So are you essentially doing prompt engineering for us, trying to improve this web application simulation animation thing?
Yes, you could say that. I'm essentially helping you refine the instructions or prompts for the animation design to achieve a more effective and clear representation of the counterfactual reasoning concept. It's about guiding the development to better communicate the intended message.
Okay, and what's the robot doing right now?
The model is currently updating the animation for counterfactual reasoning based on the suggestions we discussed. It's modifying the layout to show both scenarios simultaneously, adding clear indicators for the different medication paths, and using contrasting visuals to highlight the what-if comparison. It's essentially redesigning the animation to be more intuitive.
Right, it's funny how the animation doesn't work. The user interface is stuck when the agent is making modifications, don't you think?
I understand your observation. It appears that the user interface is not fully responsive or updating in real time while the model is making changes. This can sometimes happen with complex systems where updates are processed asynchronously, leading to a delay in reflecting the changes in the user interface.
Yeah, this is not such a complicated system, is it? Just a couple of very simple simulations.
You're right, the individual animations are relatively simple. However, the complexity comes from integrating them into a larger interactive system, where the model can generate and modify the content based on user input. The challenge lies in ensuring seamless interaction and updating the visualizations in real time, which can be technically demanding.
Okay, so the agent made quite a bit of quite a few changes to the counterfactual reasoning animation. Can you explain the simulation as it is at the moment?
Certainly, the updated counterfactual reasoning animation now starts with a single patient node, from which two distinct paths emerge. The first path represents the factual scenario, showing the patient taking medicine A and surviving, indicated by a solid line. The second path represents the counterfactual scenario, depicting the patient taking medicine B and their condition worsening, shown with a dashed line and a contrasting color. The animation proceeds step by step to clearly illustrate the two different outcomes based on the medication choice.
How's this animation better than what we had before?
This animation is better because it directly compares the factual scenario with the counterfactual one, side by side. By showing the two distinct paths clearly, it makes it easier to understand the what-if aspect of counterfactual reasoning. The use of clear indicators and contrasting visuals enhances clarity, making the comparison more intuitive and easier to grasp. It's a more direct and effective way to demonstrate the concept.
Yeah, I don't particularly like it. I can't put words to it. Why don't you like this animation?
Okay, I can help you articulate your thoughts. Perhaps you find it unclear or less impactful because the animation sequence is too simplistic, or perhaps the visual distinction between the two paths could be stronger. It might also be that the step-by-step reveal doesn't create a strong enough sense of comparison or consequence. Think about whether the animation effectively conveys the idea of what could have happened compared to what actually happened.
Okay, that sounds good. And also with the identifying confounders animation, again, that error. Why do you think the developer cannot sort out the error? Can we ask them to redo the bit of the code, making sure that any blue errors do not appear too early?
I understand your concern about the timing of the blue arrows in the identifying confounders animation. It seems like the issue might be with the sequencing of the animation elements, where the confounding variable is introduced too early, before the initial correlation is established. We can definitely request the developer to adjust the code to ensure the blue arrows appear at the correct moment to properly illustrate the introduction of the confounder. This should make the animation more coherent and effective in explaining the concept.
Yeah, it's kind of similar things. Similar thing is happening with the causal graph generation. The second blue arrow on the right is appearing too early, so we need to fix that one as well.
You're pointing out that the second blue arrow in the causal graph generation animation appears too early, similar to the identifying confounders animation. This means the timing of the second causal element needs to be adjusted so it appears logically after the first connection is shown. We can instruct the developer to correct the animation sequence for the causal graph generation demo as well, ensuring the elements appear in the correct order. This will improve the clarity and understanding of the causal relationships being demonstrated.
Well, it looks like the developer is deep in the trenches of animation debugging, probably muttering something about elusive blue arrows and stubborn timing issues. They're trying to refine the narrative flow of the animations, making sure each visual element appears at the precise moment to convey the intended meaning. It's a delicate dance of code and timing, like coaxing a stubborn cat to follow a script. Given the developer's description, they seem focused and determined to nail the sequencing. The chances of success are pretty good, though we can't rule out the possibility of a few more unexpected Blue Arrow rebellions before it's perfect. It's like trying to train a pixelated dragon. Sometimes it just wants to breathe fire where it wants. The developer is now implementing the timing adjustments for the animations. They're specifically working on the causal graph generation and identifying confounders animations to ensure the blue arrows appear in a logical, step-by-step order. For the causal graph generation, they're making it sequential, showing the first causal link first, then pausing before introducing the second cause. In the identifying confounders animation, they're correcting the timing, so the true causal connection only appears at the very end of the sequence, after the misleading correlation has been shown and dismissed. They've updated the code, likely using JavaScript functions like setTimeout, to implement these precise changes. It's like a digital choreography, making sure the causal relationships are presented with perfect timing for clarity. All right, zooming out. This page is an interactive demonstration of causal reasoning, designed to illustrate different causal concepts using animations. It's like a mini playground for exploring cause and effect relationships. The animations are meant to visually demonstrate concepts like how different factors can cause an outcome, how to identify confounding variables, and how to consider counterfactual scenarios. Right now, the developer has been focusing on improving the timing and sequence of these animations, ensuring they clearly convey the intended causal relationships. They've adjusted the way the blue arrows appear in the causal graph generation and identifying confounders demos to make the causal connections more intuitive. The overall goal is to make the interactive demos more effective in demonstrating causal reasoning. Okay. This bar chart shows the performance of large language models, LLMs, in various causal discovery tasks. The blue bars represent the performance of LLMs, while the gray bars indicate the performance of traditional methods. The tasks include pairwise graph generation, confounder identification, and counterfactuals. The data for this comparison likely comes from experiments or benchmarks where the accuracy of both LLMs and traditional methods is measured in performing these causal discovery tasks.
No, this is just synthetic data. It's just made up.
It's possible that the data used for this performance comparison includes synthetic data. Researchers often use synthetic data to evaluate causal discovery algorithms because the true causal relationships are known, allowing for accurate assessment of performance. However, it's also possible that the data includes real-world datasets as well. Ah, I understand. If the data is all synthetic, that means the causal relationships were predefined in the generated data. This allows for a controlled environment to test the accuracy of both the LLMs and traditional methods in discovering those causal relationships. The chart then shows how well each approach performs in identifying these pre-established causal links. Yes, that's a good observation. The initial interactive demos might be designed to illustrate the concepts step by step, while the replay animation simply repeats the entire animation. We can definitely ask the developer agent to clarify the difference in behavior between the interactive demos and the replay animations. The developer explained that the initial interactive demos are designed to play through step by step automatically when the page loads. The replay animation button is then used to rerun that same detailed sequence again, allowing users to watch it closely if needed. So there is no difference in the animation itself between the initial playback and the replay. I see. You're concerned that the animations, particularly in the identifying confounder section, might not be playing through correctly upon refresh, with some elements appearing too early? I can definitely review the code for those animations to ensure they play exactly as intended, step by step, after each refresh.
No, wait,
We'll
we
make
have
sure the
another
animation
developer. We
sequence is...
have another developer. Can you just generate the full prompt for the developer to address this in detail?
Sure. I can generate the full prompt for the developer. It would say something like, the animations in the identifying confounder section are not playing through correctly upon refresh. Some elements appear too early, and the intended sequence is not consistently displayed. Please review the code to ensure these animations play exactly as intended, step by step after each refresh. The goal is to ensure a clear and accurate demonstration of the causal concepts. Does that sound right?
So this might be happening with the causal graph generation as well. Maybe we can refine that as well as a separate prompt.
Yes, absolutely. We can create a separate prompt for the causal graph generation section. It could state,
The animations in the causal graph generation section are not functioning correctly upon refresh, similar to the identifying confounder section. Please ensure that all animated elements play in the intended sequence and are consistent with the initial demonstration after each refresh. The aim is to provide a clear and accurate demonstration of the causal graph generation process. This should help the developer address the issue effectively. All right, here's a playful request. Hey there, curious explorers of the digital realm. Don't be shy. Venture over to this fascinating website and prepare to have your minds tickled with knowledge. Once you're done marveling at the wonders it holds, unleash your questions with a playful curiosity, like you're probing the secrets of the universe itself. And hey, if you found this digital playground intriguing, why not show some love? Hit that like button, subscribe for more mind-bending adventures, and join our community of knowledge seekers. Let's make the internet a hilarious and enlightening place, together. How's that for a bit of fun?
Yeah, that might have been a bit too much, but let it be.
The developer is currently restructuring the code to fix the animation issues. They are ensuring that all animated elements are properly loaded and played in the correct sequence after each refresh, specifically for the sections identifying confounders and causal graph generation. They're using a window.load event to make sure all visual elements are loaded before the animation start. Sure. I'm re-examining the identifying confounders and causal graph generation sections. I see that the animations are still not playing consistently with the intended sequence after refresh, particularly with some elements appearing too early. I will generate a revised prompt for the developer to emphasize this issue and ensure the correct playback sequence for both sections.
Pow. We lost the prompt engineer. So I might finish up. Let me know if there's any questions. Go check out the website. Let me know what you think. And like, subscribe, you know what to do. We have Patreon, all of the shebang. And eventually this will make its way to the website as well. So you could play around with it. Any more meaningful questions will be welcome as well. I can answer them next time. I'll see you in a bit. Bye.